Alberta just signed a desperate truce, a pact made not with guns, but with water meters. A document signed on April 19, 2024, that forced cities, industries, and farmers into the largest voluntary water sharing agreement in the province's entire 119-year history. And if it fails, a huge part of Canada's food supply is at risk. Right now, over 600,000 people in rural Alberta depend entirely on a source of water they cannot see, an invisible reservoir buried deep underground. And for the first time in living memory, that reservoir is failing. Wells are running dry. The ground is falling. The water that fell as rain during the last ice age is being pumped to the surface and consumed in a single growing season. This isn't a story about a dry spell. This is about a collapse, the slow-motion disappearance of a resource that was supposed to be permanent. This isn't just a local story. What happens here is a preview for farm belts everywhere. Tell us in the comments what the water situation is like where you live. Let's begin. A huge number of you who watch these reports aren't subscribed. If you value this kind of deep dive investigation, hit that subscribe button now. It's the only way we can keep making them. It's that simple. Alberta's farm belt was never supposed to be green. The entire agricultural miracle of southern Alberta, the seas of golden canola and wheat that feed millions, was built on top of a warning, a prophecy written in the journals of men who walked this land when it was still a blank space on the map. In 1857, a British geographer named Captain John Palliser led an expedition across the vast, undocumented western Canadian prairies. His mission was simple: determine if this land was suitable for settlement. For 3 years, from 1857 to 1860, he and his team surveyed, measured, and mapped. They endured brutal winters and blistering summers. They documented the flora, the fauna, and most importantly, the water. His final report to the British government was unambiguous. He identified a vast, semi-arid steppe, a triangular region stretching across what is now southern Alberta and southwestern Saskatchewan. He called it the Palliser Triangle. His conclusion was stark. The region was too arid, the rainfall too scarce, the soil too poor for reliable crop cultivation. He designated it as an extension of the Great American Desert, a place to be crossed, not settled. Another explorer, Henry Yule Hind, led his own expedition in 1858 and came to the exact same conclusion. The land was hostile to the plow. By every measurement nature had to offer, this was a place where a large-scale agricultural society simply could not survive. And yet, today, it is the heart of Canada's irrigation agriculture. The prophecy was ignored. In the 20th century, a new kind of explorer arrived. Not geographers, but engineers. They saw Palliser's desert not as a limit, but as a problem to be solved with concrete and steel. The Prairie Farm Rehabilitation Act of 1935, born from the devastation of the Dust Bowl, was the first shot fired in a war against aridity. Then came the Great Irrigation Districts, the St. Mary River Irrigation District, the Eastern Irrigation District, the Bow River Irrigation District. A web of canals, reservoirs, and dams began to spread across the triangle, carrying water from the Rocky Mountain rivers to land that had never known such abundance. Combined with this surface infrastructure was the silent revolution happening underground. Thousands upon thousands of wells were drilled, punching 30, 50, even 150 meters deep into the earth. They tapped into ancient aquifers, vast underground stores of water that had been accumulating for millennia, water that fell as rain and glacial melt 10,000 years ago. The transformation was absolute. The Palliser Triangle, the land declared a desert, became one of the most productive agricultural zones in the world. It now produces over 60% of Canada's irrigated crops. A multi-billion-dollar industry built on a technological defiance of nature, a human-made oasis. And that oasis is now starting to look like a mirage. The engineering worked, the harvests boomed, but the bill for defying Palliser's prophecy is finally coming due. The snow that feeds the rivers is diminishing, the rain is less reliable, and the ancient water being mined from the ground is not being replaced. The desert that Paliser mapped is reasserting itself, not on the surface, but from below. We're 3 minutes in, and the numbers are already staggering. If these statistics shock you, let us know in the comments. It helps us understand what information is hitting the hardest. The problem in Alberta is a war on two fronts, the visible war and the invisible one. First, the visible war, the water you can see, the rivers flowing out of the Rocky Mountains, the Bow, the Oldman, the Red Deer. These rivers are the lifeblood of southern Alberta's irrigation system, and that lifeblood is thinning. The primary source for these rivers is not rain. It's snow, the vast, deep snowpack that accumulates in the mountains all winter and then melts in a predictable spring pulse, filling the reservoirs and canals just in time for the growing season. For a century, that pulse was the reliable heartbeat of Alberta agriculture. That heartbeat is becoming erratic. Dr. John Palliser, one of Canada's foremost experts on water resources and climate change, has documented this with grim precision. His research shows that since the 1950s, the Rocky Mountain snowpack has decreased by an average of 15 to 25%. The glaciers that act as a frozen savings account for hot, dry summers are shrinking. The spring melt is coming earlier, faster, and with less volume. The province of Alberta has 9.73 billion cubic meters of licensed water. Of that, agriculture is allocated 4.31 billion cubic meters. That's 44.3% of the entire provincial water budget. To put that number in terms that means something, it is enough water to fill over 1.7 million Olympic-sized swimming pools every single year. And 98% of that agricultural water is used for irrigation, concentrated almost entirely in the dry southern farm belt, the very land Paliser warned about. So when the snowpack shrinks and the rivers run low, the first and biggest user feels the pain. Irrigation districts faced with less water in the reservoirs have to cut allocations. This is where the second front of the war begins, the invisible one. When a farmer is told his surface water allotment is being cut, he doesn't just watch his crops wither. He turns to the one source of water he controls. He turns on a pump. He draws water from a well drilled deep into his own land. He pulls water from the ground. This is the great illusion. It looks like a solution. It feels like security. But it's a slow-motion bank run on a finite account. As Dr. Pomeroy warns, we have to make sure we're managing groundwater and surface water as a common resource. If we deplete one, we're depleting the other. It's a perfect destructive feedback loop, a doom loop. Less snow means lower rivers. Lower rivers mean less water for irrigation canals. Less irrigation water means farmers pump more groundwater. And here is the fatal connection. That groundwater is what naturally seeps back into rivers, providing their base flow during dry periods. So the more groundwater you pump, the less water makes it back to the rivers, which makes the rivers even lower, which forces even more groundwater pumping, burning the candle at both ends, draining the glass while simultaneously poking holes in the bottom. And the water they are pumping is not from last year's rain. It is fossil water, relics of the last ice age, trapped in deep geological formations. It is a one-time inheritance, saved up over 10,000 years, and it's being spent in a handful of decades. For the 600,000 rural Albertans who have no access to municipal water, no pipe connecting them to a river, this is not a theoretical problem. Their wells, their homes, their farms, their entire way of life are tied to this disappearing ancient resource. And the water levels are dropping. If you find this investigation valuable, take a second to hit the like button and share this video. Sharing it with just one person, maybe a family member who lives in an agricultural area, makes a huge difference in spreading awareness. We'd really appreciate it. The most unnerving evidence of this collapse isn't coming from a well in Alberta, it's coming from space. In 2002, NASA launched a mission called the Gravity Recovery and Climate Experiment, GRACE. Its purpose was audacious, to weigh the movement of water across the entire planet from orbit. The two GRACE satellites circle the Earth, one chasing the other. They are sensitive enough to measure minute, almost infinitesimal shifts in the planet's gravitational field. And water is heavy. When a massive amount of water is removed from one part of the globe, whether it's melting ice sheets in Greenland or a draining aquifer in India, it leaves behind a slightly weaker gravitational signature. The satellites detect this. They are, in effect, weighing the water from 500 kilometers up. Drive J. Famiglietti, a hydrologist who pioneered the use of GRACE for tracking groundwater, put the technology to work and revealed a terrifying global picture. 1/3 of the world's major aquifer systems were in a state of stress or decline. They were being drained faster than nature could refill them. What the GRACE satellites show on a planetary scale, a network of wells on the ground is confirming with chilling local specificity. The Alberta Groundwater Observation Well Network, or GOWN, is a collection of over 200 monitoring wells strategically placed across the province. They are the dipsticks for Alberta's underground reservoirs. For years, they have been sending back unsettling signals. But after the consecutive drought years of 2021 through 2023, the signals turned into alarms. Dr. Masaki Hayashi, a hydrogeologist at the University of Calgary, tracks this network closely. His assessment is blunt. It's been another year of drought. Now these wells are hitting all-time lows. Not just low, all-time lows. Lower than the Dust Bowl in some places. Lower than any point since record-keeping began. The most damning piece of evidence comes from a place far from the intensive agriculture of the Farm Belt. It comes from the Marmot Creek Research Basin in Kananaskis Country, a protected, pristine mountain environment west of Calgary. There are no large farms here, no industrial users, no towns overpumping the local supply. This well measures the true, undisturbed health of the aquifer system, fed directly by mountain recharge. And it is at its lowest level since the 1970s and 1980s. This is the smoking gun. It proves the problem isn't just overuse by farmers in one district or another. The entire system is failing. The natural recharge from the mountains, the very source of the water, is in a state of systemic climate-driven collapse. In the most heavily stressed agricultural zones, like parts of the Buried Valley aquifer system near Edmonton, the ground is literally falling. Water levels have been recorded decreasing by up to half a meter every single year. The water is pumped out, and the porous sandy layers that held it begin to compact. The land subsides, a hollow space, and absence is growing beneath the surface, an absence that you can now measure with gravity from space. The crisis had been building in the data for years, a slow creeping catastrophe documented in scientific papers and government reports. Then in the winter of 2023 and the spring of 2024, the catastrophe stopped being academic. It became an emergency. We're deep into the crisis now. And if you're still watching, you're exactly the kind of person this channel is for. I know, I'm reminding you again. But a shocking number of people watch these entire reports and forget to subscribe. Please, take 1 second. It's a crisis for our subscriber count too. The winter of 2023 was one of the driest on record. The snowpack in the mountains was disastrously low. The reservoirs that supply the cities of Calgary and Edmonton and the vast irrigation networks of the South were not refilling. Agroclimate specialists like Trevor Hadwin at Agriculture and Agri-Food Canada warned of extreme subsoil moisture deficits across the entire prairie region. As spring 2024 approached, provincial authorities looked at the data and faced a scenario that had, until then, been unthinkable. Projections showed that rivers like the Oldman and the Bow could see flows that were 50% below normal. There would not be enough water to satisfy all the licenses. Not for cities, not for industry, and certainly not for farms. Without intervention, reservoirs could be drained to levels that would threaten municipal water intakes. A system collapse was no longer a future possibility. It was months away. So, the government of Alberta, led by Environment Minister Rebecca Schultz, did something no government there had ever done. They called a truce on April 19, 2024. After weeks of tense, closed-door negotiations, the province announced it had brokered 4 landmark memorandums of understanding. These were not new laws. They were voluntary agreements between the 38 largest water license holders on the Bow River, the Oldman River, and the Red Deer River. Historic rivals, sprawling irrigation districts, major cities like Calgary, and industrial players all agreed to voluntarily use less water. It was a wartime measure, the first of its kind in Alberta's 119-year history as a province. Municipalities were asked to cut their water use by 5 to 10%, but the real sacrifice came from the irrigation districts. The St. Mary River Irrigation District, Canada's largest, serves about 160,000 acres of prime farmland. In a normal growing season, a farmer in that district would be allocated about 15 inches of water per irrigated acre. In 2024, because of the drought and the sharing agreement, that allocation was slashed to just 8 inches. That is not a minor adjustment. That is a cataclysm. For a farmer growing thirsty crops like potatoes or sugar beets, 8 inches of water is the difference between a harvest and a total write-off. It dictates what you can plant, if you can plant at all. It means turning off the taps mid-season and praying for a rain that the climate models say is less and less likely to come. It means fallowing land that has been productive for generations. The agreements were hailed as a triumph of collaboration, a necessary, painful step to prevent a far worse outcome. But they also revealed a terrifying vulnerability. The entire agricultural economy of southern Alberta, an engine of the Canadian economy, was so close to the edge that it required an unprecedented voluntary rationing pact just to survive a single season. The truce bought them a summer. It bought them time. But it did not make it rain. and it did nothing to replenish the ancient invisible reservoirs that were being drained even faster to make up for the surface level cuts. The agreements were a tourniquet on a severed artery, but the patient was still bleeding out underground. The 2024 water crisis pulled back the curtain on another, more fundamental problem. A problem of knowledge. As the province scrambled to manage the shortage, it became painfully obvious that nobody had a complete picture of the very resource they were fighting over, specifically the groundwater. For decades, the province had relied on the GOWN network, those 200-plus observation wells, to understand its aquifers. It was like trying to understand the ocean by taking samples with 200 buckets. The data was useful, but it left vast dark spaces in between. Nobody knew the true size, shape, or volume of these underground reservoirs. Nobody knew how quickly they were truly depleting, or how, or if, they were connected. You cannot manage what you do not measure. Now, a race is on to map the void, to see the invisible. Organizations like Living Lakes Canada, working with the Alberta Geological Survey and local partners like the Oldman Watershed Council, are deploying a technology that feels like something out of science fiction. It's called Towed Transient Electromagnetic Mapping, or TEME. Imagine a helicopter or an all-terrain vehicle dragging a large hexagonal frame over the landscape. This frame shoots powerful electromagnetic pulses deep into the ground. Different materials, clay, sand, gravel, water, all conduct that energy differently. By measuring the response, hydrogeologists can build a detailed three-dimensional CAT scan of the Earth, down to depths of over 100 meters. They can see the ancient buried river valleys. They can distinguish between water-bearing gravel and impermeable clay. They can, for the first time, actually map the aquifers. The technology is incredibly powerful. A single system can gather 50,000 sounding points in a single day, creating a high-resolution image of the subterranean world that was previously impossible. This work is finally starting to illuminate the scale and complexity of Alberta's underground plumbing. These are not just uniform sheets of water. Many of Alberta's most productive aquifers are what geologists call buried valley aquifers. During past ice ages, massive glacial rivers carved deep channels into the bedrock. When the glaciers retreated, these ancient valleys were filled with sand and gravel, creating incredibly porous, productive underground conduits for water. They are, in effect, underground rivers, some hundreds of meters wide and dozens of meters thick. A hidden infrastructure created by geology over millennia. This mapping effort is vital. It's also decades late. A 2013 study by the Oldman Watershed Council on the Crow's Nest River aquifer had already flagged the massive data gaps. The report warned that without better understanding, sustainable management was impossible. The crisis of 2024 proved them right in the most brutal way possible. So now, the helicopters are in the air. The geologists, like Dr. Danielle Hirsch at the AGS, are poring over the new data, trying to build the map of a plumbing system while the house is on fire. It is a desperate race to understand a resource at the very moment it is disappearing. It reveals the central paradox of Alberta's water crisis. They built a world-class agricultural empire by tapping into a resource they never truly bothered to measure. The water-sharing agreements are signed, the mapping helicopters are flying, the conservation campaigns are in full swing, and it is not enough. The fundamental math of the Palliser Triangle remains undefeated. The region is getting hotter and drier. A warming climate means a longer growing season, which increases demand for water. It means higher rates of evaporation, so more of the water that does fall or is applied to fields is lost to the air before it can be used by plants or seep into the ground. The climate models are not ambiguous. The 20-year megadrought that devastated the Colorado River Basin and brought Lake Mead to its knees is not an anomaly. It is a preview. Paleoclimate research, using tree ring data, shows that the North American West has endured droughts far longer and more severe than anything in modern recorded history. The dry spell that hit Alberta from 2021 to 2024 may not have been the crisis. It may have been the warning shot. The temporary relief of a wet year is an illusion. A heavy snowpack or a rainy summer can replenish surface reservoirs and provide a reprieve for a season. It can give the impression of recovery, but it does almost nothing for the deep fossil aquifers. The water being pumped from 150 meters down fell from the sky when mammoths still roamed this land. A season of good rain cannot replace it. It would take centuries, if not millennia, of sustained natural recharge. Recharge that the current climate will not allow. Dr. J. Fumighetti, watching these trends globally, offers a chilling summary. Not only are things getting worse, but in some places the pace of decline is accelerating. We've been kicking the can down the road for a long time. Alberta has hit the end of that road. The April 2024 truce was an admission that the old way is broken. The advanced mapping is an admission that they are flying blind. The all-time low readings in the wells are an admission that the bank account is nearing zero. The province is caught in an impossible bind. It has built one of the world's most productive food-growing regions on a foundation of non-renewable water, in a climate that is actively reverting to the desert that its first surveyors mapped 170 years ago. The emergency agreements bought time. Time for policy to catch up with physics. Time for farmers to adapt with drought-resistant crops and hyper-efficient irrigation. Time to pray for a change in the weather. The question that hangs over every farm, every town, every well in the Palliser Triangle is whether that time will be used to manage a sustainable future or simply to preside over a managed decline. The wells are drawing from the deep past. The agreements are banking on an uncertain future. But the crisis is happening right now, and the ground beneath Canada's farm belt is quietly and visibly falling away. I'm going to say it one last time, because our survival depends on it, just like these regions depend on water. If you learned something, if you feel more informed, please subscribe.